Hi and welcome back to another dyno video. This time it's not a Rockford amplifier. I received a Pioneer amplifier and the model is GM X402. This is a 2-channel amplifier, and here on the backplate you can see the continuous power ratings. It says 55 watts into a 4-ohm load and bridged mono 125 watts. There is printed DIN 45324 at 14.4 volts. So this is not the test method I use. This was made with pink noise. So this is the reason why we don't reach the manufacturer's ratings, because I'm not testing with pink noise. Here on this side of the amplifier you can set your gain level. It reaches from 0.4 volts to 2 volts. You have a switch for all pass, high pass or low pass filter, and you have a bass boost knob. There is a knob where you can set the boost from 0 to 12 dB, and on the other knob you can select the boost frequency from 40 Hz to 120 Hz. On the other side of the amplifier you can make your power connections and the connections to your speaker system. And if you take a closer look to the connector on the amplifier, you will encounter that this is nothing else than a standard power supply connector for a PC graphics card. The Pioneer is connected to the dummy load and I start with continuous power test 1 kHz, both channels driven. That means that I connect an 8 ohm bridged mono load to the amplifier, and this value we get out of the amplifier divided by 2 is the amplifier's output power into a 4 ohm load, both channels driven. Continuous power test 1 kHz, both channels driven. There's clipping, I go back. I think we can take this value. Peak voltage is 36.8 volts. Bridged mono 8 ohms. I got around 86 watts out of the amplifier. That means 43 watts of continuous power with 1 kHz into a 4 ohm load. Continuous power test, but this time with a 50 Hz input signal. Clipping, I go back. We have an output voltage off. 36.6 volts. Instead of around 86 watts, now I have 85.88 watts. That means 42.94 watts. Let's say 43 watts. It's the same value like the continuous power value with a 1 kHz signal. Good linearity in power. Dynamic power test 1 kHz, 20 cycles. I go to the last cycle. 38.4 volts. Let's have a look at the center cycles. It's also the same voltage. Let's calculate with 38 volts. In this case we have 92.5 watts into a bridged mono 8 ohm load, and that means we have 46.28 watts of dynamic power. Also with 8 milliseconds I got the same values. The amplifier pulls out 10.9 amps. I calculated an efficiency of 57%. And now the amplifier is connected with a 4 ohm mono load. Clipping. That's okay. I got a peak voltage of 31.2 volts. Mono 4 ohms, I got around 125 watts. That means into a 2 ohm load I have 62.5 watts of continuous power with 1 kHz. I apply full power 1 kHz continuous power. 17.3 amps. The amplifier's efficiency is around 52% into a 2 ohm load, both channels driven. Continuous power test with 50 Hz. Straight into clipping. Oh. I have a peak voltage of 30.8 volts. I measured around 122 watts into a 4 ohm mono load. That means we have 61 watts of continuous power, 50 Hz into a 2 ohm load, both channels driven. Dynamic power test with 8 cycles. Looks like this. All are at the same voltage level. I go to the last cycle, check out if it's clipped or not. Looks okay. Oh, goes into clipping. I go back. I reduce. That's okay. Oh. And now we have a voltage of 32.4 volts. With 8 milliseconds, I have around 134.5 watts. That's around 67 watts into a 2 ohm load of dynamic power with 8 milliseconds. And dynamic power test with 20 cycles. All cycles at the same voltage level. Free of clipping. Yes, I go to the last cycle. And we have a voltage of 32 volts. With 20 milliseconds, I have measured 131 watts into a 4 ohm mono load. That means 65.5 watts into a 2 ohm load, both channels driven.
Now it's time for the sound test.
If you like this video, please leave a thumb or subscribe to my channel. Thank you very much for your support and thanks for watching. See you next time on the next video. Bye bye.